Question 12. The instantaneous rate of change of g of x is the same for every real value of z. What can you conclude about g of x? Well, so it should be for every real value of x, okay? Because x is our independent variable, correct? So we'll make a correction here for every value of x in the domain. So if we say that instantaneous rate of change of g of x is same for every value of x, what can you conclude about g of x? What do you think? Let's try to sketch some graphs and see, right? The only possibility, so if we have a graph like this, do you see? We see rate of change changes, correct? Graph like this, rate of change changes. Because negative, 0, positive, here it is positive, this. But how about a graph like this? A straight line. Or like this. So if you take any 2 points on a straight line, then you will find that the rate of change is same, since the slope of the line is same. Therefore, we can conclude that if the graph follows y equals to mx plus b, that means it is a line represented in this form, y equals to mx plus b, then the rate of change will be same all throughout on the domain, and it will be equal to the slope m. Correct? I have purposely taken this line in the form y equals to mx plus b because we're thinking about functions at present, and the vertical line, you see, vertical line has a rate of change which is undefined. Second, this equation is x equals to some point. In this case, let us say if we take it minus 5, then bx equals to minus 5. And third, this is not a function. Since it is not a function, we are not including this line in our discussion. And this equation cannot be used to write this particular equation, correct? Because m becomes undefined. So that's a very important thing for you to remember, and that type of questions could be there in a test at times. Okay, so the real answer is that any line which can be represented by y equals to mx plus b will have same instantaneous rate of change all through its domain, and that will be equal to slope of the line m. Okay, thank you.